Okay, according to Newton's second law, so let's assume an object like this. Suppose this is an object, and if you apply some force on this object, then like this when you apply some force on it, this object will start drifting in this particular direction. Okay, let's examine this object. When object okay, when suppose no force is acting on it, when force is 0, you can see the velocity of the object is 0. Object is in state of rest. Object in state of rest means its velocity is 0. When force will act on it, you can see the object start drifting in a particular direction. Let's assume that its velocity is 10 now, 10 meter per second now. Okay, so when you apply force on it, like when force is applied on it, this object starts motion in a particular direction like this. Its velocity from 0 is increased to 10. Its velocity was 0, now its velocity is 10. It means there is a change in velocity. There is a change in velocity from 0 to 10. So change in velocity is called acceleration. Change in velocity is called acceleration. It means acceleration is produced in it. So acceleration is produced in the object. Okay, now suppose you increase the amount of force, so there would be a large change in velocity. If you further increase the velocity, there would be a further increase in velocity. So more change in velocity will result more acceleration. So you can simply write that acceleration produced is dependent on applied force, and it is directly dependent. If you increase the amount of force, the acceleration will increase. The more you increase the force, more it will be an increase in acceleration. So acceleration is directly proportional to applied. Acceleration is dependent, so it is on left side. Force is independent, so it is on right side. So more acceleration, more force means more acceleration. Now suppose initially it was an empty box. If I would replace it with a filled box, now you can see its mass is increased. So when you increase the mass, so increase in mass, there would be small change in velocity. By increasing mass with same amount of force, there wouldn't be as much increase in acceleration. So if you increase the mass, there would be a small amount of change in acceleration. So I can say acceleration is inversely proportional to mass. What does it mean? It means if you increase the mass of an object, the change in acceleration decreases. Change in velocity decreases. So that's why acceleration and mass are inversely proportional. Now we have two types of equation. One in which acceleration is directly proportional to the force, and in second case we have acceleration inversely proportional to the mass of the object. Now let's combine them. By combining these, we can say acceleration is proportional to force and inversely proportional to mass. So you can say acceleration is k times, by removing the proportionality sign we can have force over mass. If k is 1, acceleration would be k over m, and k would be equal to, oh sorry, it's a f over m, because k is 1, so 1 is here. So force would be equal to, if I move m to the other side, it would be m times a. So this simplified version is our formula for force in next, in next chapters we will continuously use this formula for force. So this is also called the Newton's second law. Like normally we would refer it as a the equation of force from Newton's second law.